In the last lesson, we graphed polar points and we converted equations. So if I had the point 4 comma pi over 4, well, let's see, there's 90 degrees, so pi over 4 would be halfway. This would be pi over 4. So if it's going out 4 steps, 1, 2, 3, 4, here it is. 3 comma 4 pi over 3. So I would go past pi and be about a third. I think it's right here. And we would go out 3. 1, 2, 3. But what instead if I said I want all the points that are at r equals 3? Well, that would mean I'd go out 3 steps, 1, 2, 3, and then just make a circle. Let's see if that makes sense. If I square both sides, I get r squared equals 9. X squared plus y squared equals 9. That is the equation of a circle. Now, on the NumWorks calculator, if you go to your grapher and you go to the templates, there is, if you scroll down, one that says polar. And you could go to this and type in any of these equations. Now, when you're in this polar mode, it is not going to give you x's. It's giving you an r and a theta. So let's look at 2 sine theta. Oh, look, that's a circle. And it's going from 0 to 2. And so it's a circle like this. Oh, let's see what this one does. So what I'm wanting you to do here is just kind of explore. We're putting in each of these equations. 2 plus, here it's got a little bit of glare, 2 cosine theta. And I'm going to go look at the graph. Ooh, what does that look like? Almost kind of looks like a heart or something. That's pretty interesting. Let's see. Back up. Go to the expressions. And I'm going to change it to 1 plus 2 cosine theta. Ooh, that one has, it goes around and it came back and it did a little swoopy in the middle. By the way, these all have different names for them, and we're going to talk about those in a second, but right now I'm just kind of exploring. Cosine 2 theta. Oh, cool. This one turned into a 4-leaf flower. We have another one here, and then another petal over here. That's pretty cool. Let's see what happens when we put in, and I highly suggest, unless you have to start all over like I just did, that you just edit what you have instead of having to start all over. Sine 5 theta. And I'm going to go down to plot graph. Ooh, this is a 5-petal flower. So it's got one up here, and it's got one here, 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 here. Notice my pictures aren't great, so I'm not expecting a lot from you either. Now, if you're a good artist, you might be able to do these. I'm not good at it. Change it to sine of 4 theta. Let's see what we get there. I'm going to predict 4 petals. Oh, I was wrong. How many petals did I get? Got 8. So 1, 2, 3, 5, 6, 7. Oh, my pictures are beautiful. Okay. Let's go to the next one. Let's see if it'll let us square that. Oh, it says it's not handled. Okay, so what I'm going to have to do is, go back. It does not handle squaring the r. So what I'm going to have to do is square root it. So that'd be the square root of 9 sine 2 theta. So square root of 9 sine 2 theta. Uh-oh, hold on. What did it do? Do you see that it changed out from the thetas? So it needs to keep the r's and the thetas. Aha. We just got single blades there. Again, I highly suggest don't delete everything or else you start all over. Now this one, when it says sine cubed, that really means I've got to put parentheses, sine 5 theta over 2, and then outside those parentheses, I'm going to put the cubed. This one's really cool. It made a butterfly. So it has like a one wing here, big wing up here, one wing in the back, and a little extra piece there. It made a butterfly. So all of these have special names, and I'm not the best pronunciator. Limacon? Lima, kind of lima bean. This one is called a cardioid, heart shape. These are called rose curves because they make flowers. These are called circles because they make circles. Notice that's just when you have r equals either cosine or sine. When you have an r squared, you get a limnoscate, which looks like an infinity, either diagonally or horizontally. It'll be horizontal if it's cosine. So let's look and see if we can match up the equations with what they are called. So 2 plus cosine theta. Sorry about that, I got interrupted. 2 plus cosine theta. So I'm looking here, and when it has a number plus or minus these, it's going to be one of these options. So I have 2 plus cosine theta. So the A is a 2 and B is 1. So A divided by B is 2. That would be a convex limacon. R squared equals 4 sine 2 theta. That's a limnoscate. R squared equals, okay, so it's a limnoscate. Limnoscate. And it's the one that's looking sideways. 1 plus sine theta. Okay, so when it's the number plus, that's a limacon. And this plus and the amplitude of the same thing, so 1 over 1. It would be a cardioid. It'd be a heart shape. This number's smaller, so 2 plus 3 cosine. So 2 plus 3. So the A is smaller than the B. So 2 over 3 would be here. It's a limacon with an inner loop. Limacon with inner loop. what do we get? 3 cosine 2 theta. Ooh, okay, so that's going to be a petal. 3 cosine 2 theta. Okay, so we've got a number in front and 3 cosine 2 theta. So the n here is 2. When that is even, we're going to get twice as many petals. So we're going to get 4 petals. So it's a 4 petal rose. 3 sine theta. 3 sine theta. So 3 sine theta would just be this. That would just be a circle.